Good morning and welcome to this Automation Academy Mastering the Machine webinar for April 29th, 2022. The topic today was maintenance and troubleshooting in industrial automation, specifically mechanical power transmission. Hope you enjoy it. Good morning, everyone, and welcome to this Mastering the Machine webinar for the 29th of April, 2022. Today's topic is mechanical power transmission, not the most exciting topic in the world, but I am continuing my series from my book, Maintenance and Troubleshooting in Industrial Automation, which is this fun book right here. And I do have a bunch of sections released in the Automation Academy for those who are interested in downloading those sections and reading them that way. It's a less expensive method of getting access to the book. So little bit about the book. This was kind of sponsored by Automation NTH, who helped me with development of some of this material. And that's why the Automation NTH and NTH University logo is on the front of the book. So there's a little picture of the book there. What is Mastering the Machine? This is some of the necessary stuff that I cover in the beginning of the webinar. This is named after a document that I released in 2013, which was about specifying and quoting machinery in industrial automation. So you can get this document at either one of these two websites here. It is a 26-page document, and it just mostly talks about how to bid machinery and how machine builders do all that, machine building and documenting. And it's kind of evolved into a training and automation website that includes these bi-weekly webinars. So I just named it after that document, Mastering the Machine. What is the Automation Academy? So the Automation Academy is the reason that I do these webinars. It is a membership site, and it includes training videos for Allen Bradley, Siemens, and Omron PLCs. It's got some job and aptitude assistance from Ken Coleman on it. And it's got a little library of training and technical documents, which includes downloads from the book. We have a small community with interest groups that has since been somewhat downsized. I can reinstate that if necessary ever, but there weren't a lot of people using it. So I've left the groups on there. So a little bit about today's subject. I've extracted a lot of different parts of the book, and I've put them into 26 separate documents, and they are available for download from the Automation Academy. Again, this book is a pretty thick document. I don't know if you can see this here. I tried this last week, and let me see here. I can see Phil's on here. As soon as let's see, show grid video. There we go. Phil, can you see this book right now?
Yeah, I can see it.
Okay. Last week I tried this, and what happens is I think if somebody joins, their picture appears at the top of the list, and then you can't see my picture. So I was talking about something in my hand and nobody could see it, which was kind of awkward when I went back to the video, but there was nothing I could do at the time. So anyway, they're available as individual downloads, and sometimes I offer to send the individual documents to people, but it's kind of a pain to do that. So, you know, sometimes people email me and they ask me for a specific part of the book, and I'm willing to do that if I have time. So a little bit more about the book. Here is one of the links to it. I went and you know, put down some of the prices that I found online. I've mentioned this before, that until people start selling the book, I didn't have a place to put a link, but I am finding links all over the internet now. Amazon, of course, is probably the most popular one. And there are about 9 sellers there, and they price the books, as you can see here. all the other major booksellers. I think Borders also has it. I didn't list them here. Even Walmart has it, which was a little bit of a surprise. I didn't know that Walmart really sold books, but I think you have to order them. It'd be great if they all stocked at least one of the book, but that's not ever likely. So anyway, that's the list price, and these are some of the prices that I found online. So a little bit about today's topic. This is not the most exciting topic. I think people a lot of times concentrate when they talk about mechanical power transmission on the driving force, like the motors, because that's controllable, right? So servos and motors, and people talk about pneumatics and things like that. So the driving force, and then of course people talk about the driven devices like conveyors or actuators of different types. The things that are being moved, but rarely do people talk about the parts that are in between the two of them. And since this book is on maintenance and troubleshooting, I thought I would cover a little bit of that subject. So this section of the book, I'm going to go ahead and drag this over here. We kind of finished up in the last webinar on maintenance systems, computerized maintenance management systems. And I don't think I talked too much about the little exercises that are in the book, but there's one of them. And then when you get done with that exercise in this document, it moves on to some of the mechanical items that aren't motors or pneumatic actuators or servos or things like that. So talked about power transmission, and that's why I decided to kind of just go sequentially and cover some of this today. So I talked a little bit about bearings and bushings, things like that, pulleys, motors, some of the thing, and Phil's here, and Phil is an expert at this, right? Vibration. Vibration is also sometimes monitored in order to predict motor failure before an event. So I talked a little bit about that in this section. This is a fairly brief section. You can see it's only 7 pages long here, but I am going to be elaborating on it a little bit in this webinar. So here's some of the other parts of the section, and I've pulled some of these pictures out here. And there are some very general mechanical adjustments and maintenance topics here, and then another little exercise at the end that I talked about here. So, and then there's some answers in the back of the book. So I'm going to elaborate on some of these subjects here. And of course, there's a lot of other subjects in the book on motors and servos and pneumatics and hydraulics and things like that. But what we're talking about today is some of the points that are subject to failure in a mechanical powertrain. So to Phil's point, things that you might need to monitor for heat or vibration or things like that, so that you can anticipate failure points. So bearings and bushings, got a couple of those drawn here. Some people don't know the difference between bearings and bushings, right? Bearings have 2 separate parts here. Usually they rotate on balls or rollers or things like that. And then bushings are just smooth surfaces that ride on shafts and things like that. They're often made of a softer material than the shaft is, so that the bushing wears rather than the shaft. You can see here, this is a torque resistant bushing. It doesn't turn, right? So it rides in these little grooves and things. And so when you have something like that, this little device that tightens in here actually rides in that groove. That's another wear point that you would need to look at on this particular device. So couplings, I mentioned those a little bit before. These are all different things that you might need to monitor or take a look at in your powertrain. This is one of the pictures from the book, and it just kind of shows some of the connections in between a motor and a shaft. So in this case, there's a clutch brake and there's a gear motor or a gear reducer. These are really common. I get into a little bit about different types of gear reducers later. And then I put the same little pictures of couplings in here. So kind of a general description. These are definitely failure points. I've had this happen when tuning servos where these helical couplings have broken. And the problem with things like this breaking is you often can't see them. They're inside of some kind of a housing. So unless you take the housing apart, you can't really see the couplings You can't see the keys. You can't see check how tight they are or anything without taking covers off. And that can be kind of a time-consuming task there. Some other things about mechanical power transmission: pulleys are often part of this, and you might have belts or chains or things like that riding in these pulleys. Another name for pulleys, for those of you who are in maintenance, would be sheaves. These are just basically rotating wheels with little grooves in them. And so some of these are pulleys, some of them are sheaves. You don't need to worry too much about the different names there. And then I put a picture of a steam crane with some cable pulleys here. These are working with big cables. And of course, the cables themselves wear, the pulleys and the sheaves wear, and I've got a little bit of a picture of that later. The reason that people use pulleys and sometimes are for gear reduction, speed reduction, or force multiplication. So that's why you'll see these kind of things on there, in addition to just transmitting power. So this was just another little diagram I found online. Gears are much the same. You can use gears to multiply speed or torque, and put a few pictures of gears up here and things. And then something that's very common for motor control would be planetary gearboxes, which take an inline force, right? A small gear like this, and they're driven by a motor at a high speed, and then they transmit the force to this outer ring, and then the outer ring rotates much more slowly, but with higher torque. So that would be an example of the right-hand side here. So speed reduction, planetary gearboxes are typically in these ratios, 3 to 1, 10 to 1, somewhere in that range. If you get very much higher, then and this one here actually looks like it's a higher speed, but I would say the ratio is this inner gear to one of these gears, and that's basically your gear ratio. But this is very stable, inline, and doesn't have a lot of backlash, which is one of the reasons they use these planetary gearboxes. Another reason are that it's pretty compact, right? You're not putting gears just side by side. You're putting them basically in line with each other. Other devices here, put some pictures of chain drives, inverted tooth chain. And here is an example of a worn pulley. I did a little bit of research on some of the different things that people should look at when doing maintenance. And this is one of the examples, right? Looking for wear and actually measuring sheave depth for wear. And in this case, you don't need to really measure the depth. You can actually see how much wear there is because it's toothed, right? And so these edges, as they wear, tend to tear your belts up. So you want to look for things like this. And in this case, if your belts are going through undue wear, then you would need to replace pulleys or sheaves for that. So these are just another few examples. Ball screws, roller screws, these also take maintenance. A lot of times these require some lubrication, and they will put grease fittings on the outside of these sometimes that you can manually grease attached to. So a few examples there. And some maintenance considerations, different things that you would need to do when maintaining systems with power transmission in them. Just briefly put a list of these items here. You would need to inspect things, of course, first. And as I mentioned previously, that requires a lot of times taking covers off of things, which should not be done while machinery is running. But sometimes that's the only time you can do it if the stuff's running. And sometimes you actually want to observe it in operation. So if possible, you should take your covers off, of course, without things running. If necessary, sometimes you take it off while not running, and then maybe you can back up and then start the system up and observe it from a distance. That might be a little bit safer. A couple pictures here, just a tension adjustment on a conveyor and a little belt tensioning gauge, some things that I found online. Cleaning of belts is a good idea. One of my experiences, I put a cotton classing system into a Memphis USDA facility had a bunch of inspection cameras on it back in about 2000. And one of the things that happened that's a kind of a maintenance nightmare is somebody took a cover off of one of the belts on one of the motors when they were servicing it, inspecting it, and they forgot to put the cover back on. So an example of something bad that can happen in those cases, this was classifying cotton, right? It inspected little tufts of cotton, and this used to be done by human beings, but this was a way to automate this. And some little tufts of cotton got into the belts and rode around the motor and eventually heated up, caught on fire, dropped onto a conveyor, and went into the disposal area for the cotton balls, right? And it caught on fire. It did $750,000 worth of damage to that machinery. I don't know whether they just rebuilt it or exactly what happened, but I heard about this, like 10 years later. And that was an example of one of those cases where a little bit of inadvertent, lack of maintenance, I suppose, putting the cover back on. Maybe somebody was trying to do the right thing. I didn't get the full story, but they forgot to put a cover back on, and it caused a lot of damage to the system. So this is pretty brief. Since Phil's here, I figure we may just talk a little bit about whatever Phil's up to for the rest of the webinar here. Again, the next webinar will be May 14th, 2022, which is a Saturday. Again, I'm traveling, and I plan to cover some of these topics sequentially. It's a good excuse for the topic itself. Hopefully, people will see this on things like YouTube, and they can contact me, or of course, join the Automation Academy, and you can download all of these items. I put some of the pricing of the book itself. By the way, the book is selling very well. I'm able to monitor that a little bit through Ingram Spark, which is how I publish these books. The book's selling quite well, and I've also had a few people join the Automation Academy. One of the advantages of doing that is you can see these prices here. And if you join the Automation Academy for the low price of $9.99 a month, you can download all of the sections, all 26 sections. And that basically makes up the book. They're in separate sections as PDFs, and you can have them much less expensively than buying the whole book. But as I mentioned, the book's doing well. You can Google it, just Maintenance and Troubleshooting in Industrial Automation if you're interested. And that's where you can get all these different sections. It's a 384-page book, so that's an inexpensive way to get it. So Phil, what's up?
Oh, not too much. I just thought this would be a fun one to join in on, especially with the mechanical power transmission. I missed out last webinar for the CMMS systems, but that'll be a good one to go back and watch.
Well, thanks. So yeah, I didn't again go into great depth. I had a guy on here that sometimes shows up on some of the different webinars, and we talked a little bit. Again, some of this beginning stuff, my only knowledge of CMMS systems, for instance, is through ABD, and they use a kind of an obscure one. I think it's called P10 or something like that. And I've gotten to look at it a little bit. I understand the point behind them, but I don't use the software myself since I'm not in maintenance and things, but I did mention it in the book a little bit. Of course, vibration monitoring is one of your specialties. So yeah, this would definitely apply.
Oh, absolutely. There's a variety of technologies that can be used for a lot of the different areas you mentioned. So besides just bearings, you had things like belt drives and some of the worn pulley kind of inspections and things. So beyond just vibration, maybe some type of visual system could help detect the worn pulleys, or potentially vibration as well. But that would be kind of an interesting one now, and is a little bit different, where the problem's fairly obvious, but if the machine is on and rotating, and you can't necessarily put eyes on that when it's rotating, that's
Right.
where some type of monitoring technology may be exceptionally useful.
Exactly. One of the things I'm working on right now is I'm building some new panels for machine vision. I have some Cognex cameras and some Keyence equipment, and I'm rebuilding those for machine vision classes. But one of the things that's in the book is something interesting that Automation NTH does, which is they put webcams throughout their machines. And it's not a matter of automatically inspecting things. They can go and pull video footage to watch any part of the machine at any time. And so if something does fail, they can see why it failed. And of course, they can just bring up archived video. Things are getting so inexpensive now, and that's a much less expensive way than buying things like Cognex and Keyence for formal inspection, to simply look at video feeds of things. And I remember you've put some infrared imaging, and I've got one of those also, just a little Raspberry Pi connected cable. I haven't done anything with it as far as actual inspection, but it is really neat and shows good images. And of course, those things are so inexpensive. I think I mentioned last time I got 4 of them, I want to say, for like $16. I thought it was one for $16, and I ordered it, and four little cameras were in the package. So incredibly inexpensive.
Yeah, absolutely. And those can be scaled out to do automated inspections depending on the quality of the cameras and that type of thing. But just a lot of the challenges arise with setting up the infrastructure to get the camera streams, ensure they're reliable. So there's a lot more to it than just grabbing a few devices and plugging them in. You want to ensure that 6 months later that it's still functioning and that you can pull it up, because why install something if a few months later it's not going to work?
Well, I tell you what, at the cost of $16 for 4 of them, the time is much more valuable than the camera. So I could see putting one of these cameras, inside of a housing or something, and like looking at the edges of, where the belt's riding and things like that. It'd be not a very exciting subject, but if you could even just monitor it for failure, in other words, if the camera itself stops feeding, then that's the alarm, that, okay, it's time to go replace the $4 camera, which of course takes time and everything. But you could monitor these and simply look at pictures, 1 week apart, and you could probably see a wear on a pulley or fraying of a belt or things like that, and not even automate it. I think the video footage itself is worth quite a bit, but of course that takes a human being doing the checks. So did you do a kind of a vision application with the Raspberry Pi camera that you had, the one with the infrared? I know I noticed it following a face around. It was able to at least.
Oh, sure. Yeah, that video on YouTube. So yeah, that's would be kind of a machine vision use case where initially during the COVID-19 pandemic, there was kind of a desire for people to do temperature checks prior to entering a business or a facility. And so I kind of created one for my house just for fun. It seemed like an excellent project to do. And yeah, it's basically an edge-based temperature detector for skin surface. Now, if you get to the root of the cause on whether skin temperature is a good indicator of infection, that's kind of one debate that some people have, but I was doing it more for a project, not necessarily to detect COVID-19. So yeah, basically in that project, a person approaches the door, the face is kind of detected within that box. And so the box follows the face as it moves through the frame. And then the next part of the code says, inside of this box, what's the highest temperature? for most applications, that would be a person's body temperature of, 98 degrees. I guess this wouldn't work in Arizona. If it's 110 degrees outside, you may have to pick something else. But in my area, it was winter time and, below 98 degrees outside. So focusing on the hottest area and then reporting that value back. I was using MQTT, so I just transmitted that back to the broker and, had a value that was published with what the temperature was. I thought it would be kind of fun to feed it into like a locking mechanism to say you can only unlock this door if your body temperature is below a certain amount. But that would be a little bit beyond the goals of the project.
Well, I see two applications for that, even just in this picture right here. One would be, a sign of failing components is often heat. And if it does, a few degrees temperature difference, that would be pretty important. If you were watching, belts heat up or chains heat up, things like that, bearings, even if it was a kind of a wide temperature swing, you could at least monitor the difference. And then, of course, in this case, tracking of the edge of the belt. What I see here is this belt was riding pretty far over, and of course it's probably rubbing up against this side, so the belt wasn't tracking very well in the first place. And so being able to pick that up with an inexpensive camera could be pretty valuable. I don't know how rugged it would be. That's the one thing about those cameras. They're pretty inexpensive, but they're very small and 3 volts or something like that, and not in a very good housing.
Sure. Sometimes just something as simple as a contactless thermometer, it might be an IR thermometer, but sometimes that can be cheaper than a full image application. Sometimes the best approach is just simply an alert that says, hey, someone go and look at this, rather than try and diagnose automatically. Sometimes it's easier just to flag it and
Yep.
say, someone go and look.
Yep. People schedule these maintenance, right? Scheduled or periodic maintenance is often done on this, but if you can't take the cover off of something easily, right, you could have something inside that could be monitoring, things like wear or looking for little fragments of, pieces of the belt coming off the side or cracks or whatever. So I can see some value in that. How hard were the tools to use for those small cameras, machine vision tools?
Some coding required. We'll put it that way. There's a lot of libraries that have become available to do the things that people want to do. So tracking a face is fairly simple now. If you import a library and push run, in whatever software you're using, typically it works pretty well out of the box. Most of these are free. So there's something called OpenCV, Open Computer Vision, and that's utilized for many Raspberry Pi projects, as well as professional and commercial applications as well.
Wow.
So you'll start to see a lot of that in years to come.
Yeah, one of the things I'm finding, of course, working with automation NTH is that, machine vision is getting better, but it's also seems to be getting even more expensive. I know there were some low cost, banner and things like that had in the $1,000 to $2,000 range for cameras, but now the Cognex cameras, even the small ones, are starting to put more capability in them. Basically fuzzy logic, machine learning kind of stuff. They have this VIDI project that kind of learns as it goes, right? You can just keep teaching new use cases for it, and it literally does machine learning, but the cost is getting up there, $7,000, $10,000. Sometimes you pay more for the software itself. So I think, low cost things like this, especially for just, even a person going and periodically looking at video, could be super valuable. Um,
Yeah, absolutely. A lot of times when you start to get into the questions of how much processing needs to be done on the device itself versus can we send one picture to the cloud once a week for monitoring, I think that's where some of those questions start to create different use cases. And so if the goal is to monitor a worn pulley over a long time period, if you snap a picture once a week and send it to a different destination, so a cloud location for analysis, that would be perfectly fine. Whereas something that needs very instantaneous analysis or some type of outcome very quickly, based on what that computer vision system is detecting, you may want to do that at the machine level or at the edge, on that device attached to the machine. And the reason being is if there is a disruption in the internet, you wouldn't want some type of failure to occur because your machine vision application wasn't operating correctly.
so I wonder if there are
Yeah.
cloud companies that do that analysis for you, or would the reason be that the software for the analysis would be maybe too expensive for individuals, so they would subscribe to a analysis service for things like that?
Yeah, I think it's really dependent on the size of the application, because it comes down to the make it versus buy it kind of approach.
Mm-hmm.
And so if you have individuals in your company or your organization who are capable of managing remote systems and capable of doing the data analysis, you probably wouldn't want to subscribe to a service that does the same thing if you have staff in-house that can do it. But that's typically larger organizations. If you're a smaller outfit, you might not have the time or staff necessary to set up a whole new system for a monitoring application. And in that case, one of the subscription services where you pay X dollars per point that you're monitoring may be more economical.
Yeah, speaking of small facilities, I am going back to ABD, American Beverage Depot, in a couple weeks for about a 2-week period. And they're starting to get serious about having to do more on the SQF certification. So, in addition, they're adding a new line. They've apparently got some new business and are, having to kind of enlarge their capability without being able to enlarge the facility. But we're going to be talking about, of course, that, and of course, the owner's back, which is nice.
Oh, fantastic.
Yeah, he's been asking me to come down there for a while, but I'm really trying to get him to solidify specifically what are we going to be working on. And he's working on so many different things. I've been looking for other resources in South Florida to do things like panel building and installation of things and design, right? CAD design, things like that. So I've gotten a lot of responses from people outside of Florida, but as I've mentioned, since I travel up and down from here to there, I'd like to be able to stop in, find somebody fairly close that I can at least check the work to make sure that there's nothing, extraordinarily out of spec. People offer from overseas, I can do your, design for you. Well, it's nice to be able to sit down face to face with somebody. So I'd love to find somebody in that area, but yeah.
Well, sure. That area does seem to be growing. So hopefully some people with that background show up.
Yeah, hopefully. Yep. Well, anything else major? Are you still working with some of your Oak Ridge stuff or University of Tennessee stuff?
Yeah, a little bit. That's kind of backed off a little bit now that I'm assuming in different position, but yeah, absolutely.
Okay, that's a good deal. I'm still, of course, working with the NGH a couple weeks a month. Finish the book out. That's good. That's a little bit of a relief. I am writing a bunch of material on HMI programming right now. I have a training class coming up with Nissan, and they want some source material. So I'm kind of writing things the way I normally do, just go do a bunch of research and get information from other places and form it into a ball and present it. Specifically, they're doing RS View or RS Factory Talk ME, which is an Allen Bradley HMI program that they use there. But I'm trying to get some good general, conceptual HMI and SCADA information to present to them also. So that's something else that's coming up. It's filling up my time pretty well. I still would love to get back to our monitoring discussion, with the PhotoEyes, the remote monitoring. I still think that has a lot of potential in it, but again, it would be nice if somebody else got excited about it, excited enough to kind of drive me and you and pay for it. That's ultimately, pay for the time that it, the hardware costs and everything's not a big deal, but the time that it takes to create something like that and prove that it's rugged is I think it's a decent amount of time. Again, the next webinar will be May 14th. It's on a Saturday. And once again, that's because I'm traveling, going to Raleigh to teach a class next week, then training at NTH all week, and then having to go to Miami. So that's why it ended up on a Saturday. And of course, always encouraging people to check out the Automation Academy, and lots of videos on there and downloads and things like that. And of course, I'll post this on YouTube, and we'll see you guys later.